Hello, my name is Muhammad Haris Izzuddin, and today we are going to talk about Hamming window from the subject digital signal processing. Meet our teammate Lia Leila Isabella B0822100349 and myself Muhammad Haris Izzuddin bin Ibrahim B0822100359. Next is the table of content. We have 6 sections: objectives, equipment, synopsis and theory, procedure, results and discussion, and lastly conclusion. There are 3 objectives. First is to demonstrate the design of FIR filter using Hamming window and analyze the characteristic and difference with rectangular window. Next is to explain one application of each filters, showcasing its effectiveness in signal processing tasks. And finally, being able to work in team to deliver clear and engaging content through a well-organized report and video representation. The equipment that we use is a Windows 11 laptop and the MATLAB software. Next is the synopsis and theory. A Hamming window is a windowing function used in signal processing to concentrate the energy of frame on the spectrum, reducing signal edge disparity by multiplying each frame with a specific function. Meanwhile, rectangular window in signal processing is a type of signal used to highlight a specific part of another signal by multiplying the input signal by the rectangular window signal. Now, we are talking about the differences. There are 4 kind of differences that we can suspect. The first one is the side lobe suppression. Hamming window has a good side lobe suppression. It reduces spectral leakage significantly. Rectangular window has a poor side lobe suppression that causes it to have high spectral leakage. Next, we have main lobe width. Hamming window has a wider main lobe compared to rectangular, making it has a poorer frequency resolution. Meanwhile, the rectangular window has a narrower main lobe, creating a better frequency resolution. Talking about frequency resolution, Hamming window has a lower frequency resolution due to wider main lobe, which mirrors closely spaced frequencies. Rectangular window have high frequency resolution due to narrow main lobe, which is ideal for resolving closely spaced frequencies. And lastly, the ringing effect. Hamming window has minimal ringing effect due to tapered edges that reduces abrupt transitions, while rectangular window has pronounced ringing effect due to sharp transition at the edge of the window. That is all from me. Now, I give it to Lia Leila Isabella.
Hello, I am Leah and will be presenting the procedure, result, discussion, and conclusion. So for the procedure, first is understanding the Hamming window and rectangular window. Next is designing, where we plot impulse response analysis and frequency response analysis for both Hamming window and rectangular window. Lastly, the application, where we use speech signal smoothing with Hamming window filter and pulse signal processing with rectangular window filter. So first, we want to understand the Hamming window and rectangular window. So we have our parameters here. Then we want to define the windows. So for Hamming window, we use the command Hamming bracket m plus 1, whereas for rectangular window, we use the command recwin bracket m plus 1. Now, we will plot the windows by using the command stem and use subplot so we can observe both windows in one figure. So this is the result of it. Next is designing the window filters. So first of all, we want to plot an ideal impulse response. Make sure we have the same parameters and define windows as previously stated in the workspace here, or just typed in the editor before plotting. Then, we determine the cutoff frequency and the ideal response. Lastly, we apply the windows before plotting. Again, we use the command stem to plot and subplot to observe both windows in one figure. Moving on to the frequency response analysis. Again, making sure the parameters and defined windows are the same as previous in the workspace here or typed in the editor before plotting. We use the command freq to compute. This time we use command plot and both windows will show output at the same graph. We make sure to differentiate it, where Hamming window is the black solid line and rectangular window is the blue dashed line. We include the legend to avoid confusion. And here is the result. Diving into the application, we will generate a noisy speech-like signal for the Hamming window. Again, the parameters and the defined windows should be present in the workspace here or typed in the editor before plotting. We have our sampling frequency, time vector, and sine wave with noise over here. Then we use the command filter to apply it on the signal. We plot both the noisy signal and filtered signal. We also differentiate them by ensuring the noisy signal will be blue and the filtered signal will be black. And here is our result. Lastly, we want to generate a pulse signal for the rectangular window. With the same parameters and defined windows at the workspace here or typed in the editor, we generate the pulse signal. Then we apply the filter using the same command as the previously. Next, we plot the results where both signals will be on the same graph. We differentiate them by assigning the blue color for the pulse signal and the black color for the filtered signal. Here is the results. Next is the result and discussion. This is understanding Hamming window and rectangular window. As we can see here from our right, the result we obtained from the coding that we did. We can see how the Hamming window shows a smooth tapering shape that reduces the amplitude gradually towards the edges. The tapering can minimize abrupt transitions in which it can reduce leakage in the frequency domain. However, the rectangular window will show a constant amplitude across the length. The cutoff can abrupt transitions, which results in higher side lobes and greater spectral leakage. Moving on to designing, we plot the impulse response analysis for both Hamming window and rectangular window. The results that obtained are shown where the top is the Hamming window filter and the bottom is the rectangular window filter. From here, we can observe how the Hamming window is smoothly tapered at both ends with less abrupt transitions. Nevertheless, the rectangular window displays sharply truncated in which there is no tapering at the edges due to the uniform amplitude. Now for the frequency response analysis. The results here shows where the black solid line is the Hamming window and the blue dashed line is the rectangular window. From what we can observe is how the Hamming window has greater side lobe suppression with a significantly reduced spectral leakage. However, this came at the cost of slightly wider main lobe where it can reduce the frequency resolution. In contrary, the rectangular window shows higher side lobe levels in which leads to more spectral leakage. Despite this, the main lobe is narrower and can provide a better frequency resolution. Diving into the application, we use pitch signal smoothing with Hamming window filter. From the results here, the blue signal is the original signal and the black signal is the filtered signal. This output displays a significant noise reduction while also preserving the sinusoidal characteristics of the original signal. From this, we can observe how the Hamming window can suppress unwanted spectral components. Therefore, the Hamming window is ideal for applications that requires clean spectral separation like speech enhancement and audio noise reduction. Lastly, we use pulse signal processing with rectangular window filter. From the results, the blue pulse is the original pulse and the black pulse is the filtered pulse. This output displays sharp transitions but also shows ringing effects due to rectangular window's poor side lobe attenuation. Nevertheless, the rectangular window is great at providing high frequency resolution, which makes it suitable for tasks such as radar signal processing, where it is needed for resolving closely spaced frequency components. In conclusion, the design analysis of the FIR filters, Hamming window and rectangular window shows the difference between the side lobe attenuation and frequency resolution. From this, we can recognize the importance of selecting the appropriate windowing method based on specific signal processing tasks. The Hamming window will show a smooth impulse and strong side lobe suppression. It is effective in reducing spectral leakage, which makes it suitable for applications involving noise suppression and signal clarity. On the other hand, the rectangular window will show a sharp impulse response and higher side lobe levels. It provides better frequency resolution but increases spectral leakage. Thank you.